maximum displacement of a particle from its mean position. From its mean position. It is a disturbance that travels through what?
A medium.
Now, the medium can be what?
It can be
A medium can be what? Wave can be classified into what?
transverse and longitudinal waves.
We have the transverse and what?
Longitudinal.
What are the types of waves we have?
We have water wave, light wave.
We have the mechanical. We have the mechanical wave. And we have the what? Electromagnetic wave. It is under these two that both the light, the sound, the X-rays and all these things is what? Classified. We have the types of wave and we have the classes of what? Wave. The classes of wave is the what? The transverse and the what? Longitudinal what? Wave. But in the types of wave, it is the what? The mechanical and the what? Electromagnetic what? Wave. What do you understand by mechanical wave?
Mechanical wave is a wave that needs a material medium for the propagation.
And needs to what? A material what? Medium for the propagation. Example.
Sound wave.
Sound wave.
Light wave. Water wave.
Electromagnetic wave is what?
They do not require a material medium.
It does not what? Require what? A material medium. Example.
Gamma rays.
X-rays and the what? Rest. A wave is a disturbance. A wave is a disturbance which travels through a medium. A wave is a disturbance which travels through a medium, transferring energy from one point to another. Transferring energy from one point to another without permanent displacement. Without permanent displacement of particles. Without permanent displacement of particles of the medium. Without permanent displacement of particles of the what? Medium. Wave can be classified into two. Number one, the longitudinal wave. Number two, the transverse wave. Wave classified into two. Number one, the longitudinal wave, and number two, the transverse wave. Types of waves. Mechanical wave. Don't enter this class. Mechanical wave and electromagnetic wave. Mechanical wave and electromagnetic wave. Terms in waves. Terms in waves. Terms in waves. Number one, vibration. Number one, vibration. This is one complete oscillation. Vibration. This is one complete oscillation. That is the to and flow movement about a fixed point. That is the to and what? Flow what? Movement about what? A fixed point. Number two, the wavelength. Number two, the wavelength. This is the distance between one crest and another. This is the distance between one crest and another. Or one trough and another. Between one crest and another, or one trough and another. That is, wavelength can also be defined as the distance between two particles that are in the same phase. That is, wavelength can be defined as the distance between two particles in the same phase. Period or periodic time, capital T. Period or periodic time, capital T. Or periodic time. This is the time required by a body to complete one oscillation. This is the time required by a body to complete one oscillation. The frequency. The frequency. This is the number of oscillation. This is the number of oscillation. This is the number of oscillation in 1 second. This is the number of oscillation in 1 second. Or the number of complete wavelength produced in 1 second. Or the number of complete wavelength produced in 1 second. Displacement. Displacement x. This is the distance of vibrating or oscillating particle from its mean position. This is the distance of vibrating or oscillating particle from its mean position. From its mean position. Oscillating particle from its mean position. Amplitude. Amplitude. The amplitude. This is the maximum displacement of a particle. This is the maximum displacement of a particle from its mean position. From its mean position. This is the maximum displacement of a particle from its mean
Position.
position. Phase. Phase. Phase are 2 points in which a wave separated by a whole wavelength. Phase are 2 points in a wave separated. Phase are 2 points in a wave separated by a whole wavelength. All particles are the same distance. All particles are the same distance from mean position and moving in the same direction are said to be in the same phase. All particles are the same distance from mean position and moving in the same direction are said to be in the same phase. Number 8, wavefront. This is the line or circle. Wavefront. This is the line or circle. This is the line or circle joining all points in the same phase. This is the line or circle joining all points in the same phase. When we come to wave, we have something like this. We always have a diagram like this. Now, for it to complete one oscillation, here is what we call what? Here and here is what we call the what? The successive what? Crests. And this is what we call the what? The successive what? Trough. But for a wave to complete one oscillation that they are talking about, that means it must what? Pass from here to what? Here. Then here to what? Here. It's making it what? One what? Complete what? Oscillation. So it's either I want to use my what? Successive crest from here to here, or but if I'm talking about that a wave which has completed one oscillation, that means I must have what? One crest and what? A trough for it to have what? A complete what? Oscillation. Now, if it's diagram like this, because there's a time that will come, they might not give you what the number of oscillation, they will just give you a diagram. You as now the students will now be the one to what? Now use your initiative to what? Calculate the what? number of oscillation there, and that is what you are going to use to what solve your what questions. Now I'm having that what from here. And this is not why I'm here. Why I'm here is majorly the progressive wave, the reflection, refraction, the lens, the mirror, the sound, the wave particle paradox, and the rest. Because mainly, all this theory doesn't come out much. It is mainly what calculation. We just need to what ought to know it. Now, when we come to the wave, remember that we have that what? That F, firstly, we're having that what? T is equal to what? 1 over what? F. And also, that F is equal to what? 1 over what? T. We are now having that what? That my what? Wave speed or the displacement V is equal to what? F what? Lambda, which is what? Our what? Wavelength. But since F is equal to what? 1 over what? T, we're having that what? Wave what? Speed is equal to what? Lambda all over what? T. We all know how we got it. Anywhere we see F, we put it as what? 1 over T. Then 1 times lambda is what? Lambda all over what? T. And a lot of them that is what being what? Used. Now, it's a time whereby we have our frequencies what? Number of oscillation all over what? All over what? Time. Which is the period of where? To get my what? Total what? Time, which is the period. I'm having what? N all over what? Small t. If I am giving something that is revolving, that is revolving, and your time, they will tell you that this revolved 2 or 3 times. That means it oscillated. The number of oscillated, the number of each revolution. For it to complete 1 circle, it has to revolve, which is what the to and what flow what movement. Just what like what a pendulum what bulb and the rest. So time I will take Riega Nachite and working in 1 what oscillation. Now you now calculate how many oscillation it took for you to get your period. It is what? T is equal to what? N all over what? Small t. Just like in projectile, we have the what? The time taken and the what? The time of what? Flight. Okay?
Yeah.
So, velocity of wave is equal to distance traveled all over what? Time, which is this. Note, 1 circle per second is called 1 hertz. Note, 1 circle per second is called 1 hertz. Yes, 1 circle. CIRCE. 1 circle, not cycle. There is difference between a cycle and what? A circle. It's called what? 1 watt. Yes. 1,000 circle per second is called 1 kilohertz. 1,000 circle per second is called 1 kilohertz. One million per circle, or 10 raised to the power 6. 1 million per circle is called 1 million circle per second is called 1 megahertz. 1 million or 10 raised to the power 6 is called what? 1 megawatt. Yes. Then 10 raised to the power 9 circle per second is called 1 gigahertz. From the relation, it implies that the higher the frequency, the shorter the wavelength, and vice versa. From the equation, from the relation, the higher it implies that the higher the frequency, the shorter the wavelength. And vice versa. Yes. The relationship between the period, frequency, wavelength, linear velocity, and angular velocity. The relation between period, frequency, wavelength, linear velocity, and what? Angular velocity. For a wave which is in origin, the wave equation can be represented as, from a wave which is in origin, the wave equation can be represented as y is equal to a sine wt. Y is equal to what? A sine what? W what? T. Say that A motion which is in the what origin is equal to what a what sine w t. Whereby this is our what amplitude. Okay, that means we cannot be having that. But since w is equal to 2 pi what f or what 2 pi what all over what t, we can now say that what that y is equal to what a sine what 2 pi what f or what okay ft or what a sine what 2 pi what t. Okay, now we're having what times what t. Now if the two of them cancel, what are we going to have there? A sine what 2 pi. So we're having that what that y is equal to what a sine what 2 pi. No, but we have a constant. Now the original this thing says that what that a, that if I'm having that y is equal to a sine bracket what w what t minus what x. Okay, but this x is the constant which is what k. Okay, but k is equal to what, which is what 2 pi what 2 pi what all over what, is it all over lambda? So with that we are now having that what that y is equal to, I'm now having that what a sine bracket what, now having my wt anywhere I see it I will now put it as what 2 pi what f what t minus what minus what 2 pi what all over what lambda. Is it 2 pi all over lambda? Eh? Is it 2 pi all over lambda? Is it 2 pi all over lambda? 2 pi x all over what? Lambda, okay? Is it 2 pi all over lambda? I asked the question, is it 2 pi all over lambda? We are seeing all this equation. Okay, oh. Now what does they have in common here? I'm now having that y is equal to a sine what 2 pi bracket what f what t minus what x all over what lambda. But lambda is equal to what? Huh? But lambda is equal to what? V over what? Lambda is equal to what?
VT.
But my lambda is equal to what?
VT.
V over what? T. Okay? V times what? T. Or what? V over what? F. So that means anywhere I see my lambda, I can now put it as what?